Good afternoon, everyone, and welcome to today's webinar presented by the Chartered Institute of Civil Engineering Surveyors on marine projects, issues that can occur therein, and how the FIDIC suite of contracts deal with them. Just a couple of housekeeping points before we start. If you do have any questions, please do put them in the chat box. We will do our best to answer any of them if we have time at the end. I've also been told the slides for the presentation will be sent round after the event. And then finally, I should just a reminder, this is intended to be a fairly basic level course. It's not going to go into significant detail about each of the different points, not least because, as I'm sure many of you are aware, if you are dealing with a project on site, the FIDIC contracts will of course be amended in various ways. So please do just bear that in mind. By way of introduction, my name is Michael Bennett. I'm a partner at TLT. I specialise in construction disputes and have been advising on them over the last 15 years, including a number of coastal and offshore projects. I'm joined today as a double act by a good friend of mine, Mark Glennerster. Mark, would you like to introduce yourself?
Yeah, sure. Thanks, Michael. Good afternoon, everyone. My name is Mark Glennerster. I've got 37 years experience in coastal and maritime port projects all around the world, really, up to various values. You can read what it says on the sign there in lots of different countries around the world. So this was something that Mike and I discussed back having a catch up with the coffee probably last autumn, that we thought it might be something of interest to the members of the society. So here we are. So looking forward to an interesting discussion.
Thank you very much, Mark. So just a quick agenda for today. We're going to cover 4 different areas, starting with climate and sea level rise and how that links into the design responsibility provisions of the FIDIC contracts. We'll move on to site conditions and unforeseeable conditions under those contracts. Financing, which is a common problem with a lot of the projects, as Mark I'm sure will go into, and how early contractor involvement is important, and also how contractors can get comfort from the contractors to the fact that they may get paid at some point. And then finally into potential risks and ramifications on projects and how the early warning process works. So to kick us off, Mark is going to have a little chat with you about climate sea level rise, sorry.
Thanks, Mike. Yeah, so as with a lot of projects, no 2 sites are the same. But probably in the maritime world, it's more true. We have, you can have a couple of sites only a couple of miles away, and the forcing conditions, the design conditions, and also the conditions for the contractor when he gets to site can be completely different from those 2 sites. So every site needs to be considered in its own right. So some of the things that we consider are things like climate change, sea level rise. Now, in some respects, it doesn't matter what you think about climate change doesn't really care. Sea level rise is happening around the world. It's not the same in every location. As my slide says there, for example, in Northern Europe, we are quite lucky due to the retreating ice sheets 10,000 years ago. The ground is heaving a little, so we only have 300 to 500 millimeters of sea level rise predicted over the next 100 years. It does vary even around the UK. But on a project I did recently down in Guam in the South Pacific, there we're looking at a meter in that time due to various other environmental factors. Sea level rise is all done on carbon emissions set up by various climate panels. The UK have their own climate impact panel as well that advise the UK government. So for UK projects on the coast, for example, we follow the UK SIP guidelines, which do tend to change slightly every couple of years. So collecting this data, which we will talk about later on in the process in the presentation, is very important. Not only necessarily for the design, so those of us that might undertake the design of a particular project, wherever it be in the world, but also important for the contractor to understand the conditions of those particular sites. And they depend on several things which we'll discuss later on in the presentation. But certainly climate change and sea level rise is a very important thing that fits into the design process. So Michael, do you want to move to your next slide?
Yep. So what we're talking about here is yeah, how do you design for climate change, sea level rise? Who decides how conservative that design is going to be, and who's responsible for the design meeting those requirements? And we're going to look at three different FIDIC forms today. The first, as you can see, is the Red Book, which is the general construction contract. We're also, as I said before, looking at the unamended position. We'll then move on to the Yellow Book, which is the design and construct, and finally the Silver, which is the EPC turnkey contract. So the Red Book is it's a very traditional style of build contract, and that means it's generally employer design. It does have provision for the contractor design specified parts. That's in clause 4.1 of either the 99 or the 2017 form. The wording of the two clauses is slightly different, but in truth, they achieve a very similar position. But one of the main points to bear in mind is that without amendment, the contractor is not going to be responsible for any errors in the employer's design. We then move to the Yellow contract, which is the contractor design or design and construct, as FIDIC refers to it. Now, the contractor does do the majority of the design for this, but it is based on employer's requirements that it is given. Under the 99 form in clause 1.9, where there are errors in the employer's requirements and it causes a delay or additional cost for the contractor, then that time and cost may be subject to a claim in certain circumstances, and we'll come on to those in a minute. But the contractor's general obligation on design is to design in accordance with the contract and to comply with the criteria set out in the employer's requirements, and that's set out across clauses 4.1 and 5.1. Where the caveat comes into this, and you'll see it in the second bullet point here, is that it is in certain circumstances the responsibility of the contractor to check the employer's design, and that occurs at the outset when it's in the process of tendering and after it's given the notice to commence. So after it's been given the notice to commence, the contractor has to scrutinise the employer's requirements and give a notice of any errors or discrepancies it finds. And as it's deemed to be an experienced contractor, as any contractor doing this work should be, if an experienced contractor would have spotted those errors, then it's not going to be a variation if those discrepancies come to light later. However, if an experienced contractor would not have spotted at the tender stage or at this stage, then it may go before the engineer, and the engineer may determine that it's a variation. So, put in its simplest terms, the contractor designs to the employer's requirements, but it does have to check those are correct, but it will only be responsible for errors if an experienced contractor would have spotted them. Putting that into context with the sea level rise and climate change, you hit a bit of a funny position, because in general, the amount of engineering you're talking, or over engineering you might be talking, is a matter of client choice. But if a contractor was looking at a project, saw it had a 50-year design life, but there was no sea level rise included in the engineering assumptions or the design assumptions, it should probably be raising some questions. Moving on then to the Silver Book, which is the full turnkey contract, and this is another further step down the line. It is fully contracted design, and under clause 5.1 of the 99 form, the contractor is responsible for the employer's requirements unless, with one of four exceptions, the contract states that something is very much an employer responsibility, or it is the definition of the intended purpose of the works, and that will be very relevant when we come on to talk about fitness for purpose in a moment. If it relates to testing and performance criteria, because that's something which the employer sets out and is an employer responsibility, or it's anything that the contractor cannot verify unless the contract specifically says that they are still responsible for it. And that position remains, albeit again on slightly different wording, the same in the 2017 form. So with these three forms of contract, you do have a sliding scale of design responsibility. And one of the key things we see, which is really to be avoided, is we often find people, say, choosing the Red Book for a contractor design project and then trying to amend it down to be a Yellow Book. It only incurs additional cost. It's much better to start and choose the right contract at the outset for that type of thing. So in marine projects, what are some of the critical things to consider? make sure you are setting out your requirements accurately and covering all your bases. Do include sea level conditions, wave conditions, return periods, design lives when you're talking about design, and make sure that the information is complete as far as you can. Make your purpose of the project explicitly clear. The FIDIC contracts do include fitness for purpose obligations where a contractor is designing. Contractors, be careful, designers may not be happy to back that, so do have those conversations early. And do include a design life. But equally, contractors, be very wary of warranting a project for its lifespan. That is exactly what caught the contractor out in the Ewan and Hogarth case, where it was found that though the contractor had designed to an international standard, the standard itself was wrong. The contractor couldn't have known that, but because of the wording of the contract, it is found to have warranted the project for its lifespan, or effectively warranted its life for its lifespan, and so it was still liable despite the fact it had designed to the right standards. So Mark, I think we're now moving on to talk about site conditions.
Yeah, sure. Thanks, mate. Site conditions, yeah, on any project, site conditions, site data is important. Again, not saying that we're special in the maritime world, but we do have some strange things that we need to deal with. So our data that we collect, as I talked about on my first slide, every site is different. So generally we would try and collect some wave data. Now, we would always try and ask a client before he's even gone to tender in the concept stage to start installing a localized wave rider buoy at the site to record some localized data. That's important because often we've seen on projects where clients have relied on wave data that they've got for say 10 years. Well, 10 years isn't enough. Generally, we try and go for 40 to 80 years worth of data, wave data. The reason for that is in certain areas of the world where you have typhoons, cyclones, for example, sometimes a short 10 period of years data doesn't pick up the big storm events. So when you're doing your hindcasting and your modeling, you always want as much data as you can possibly have. The type of equipment we use for gathering site investigations, as you can see some nice photographs there. We have a jack-up barge and small vessels which use for whether it be bathy surveys or other types of surveys. They're all very sensitive to wave heights. So seasonality comes into as well, which is again I'm going to talk about in some of my later examples in the presentation. Now, of course, we need the sufficient data because if you don't, as with any designer, if you don't give them enough information, they'll start making assumptions, which of course potentially leads to a conservative design, which when you're working for a contractor is not always what the contractor wants. The contractor wants, under the yellow book, for example, to try and pull down the design as much as possible. Just as a brief example, on one particular project about 10, 12 years ago, we managed to reduce the port platform, so the top of the port, by 100 millimeters, and that saved $20 million on the project because it was a large project. So the contractor is always trying and drive you as a designer. So the more information we have as a designer, the better we can try and reduce the cost for the contractor and give value for money that way and on those forms of contract. So again, the way we collect data is a little bit different. It's very weather dependent. It's not like if we're trying to do a borehole on land, if it's a bit windy, we can carry on to do so. At sea, any more than a meter wave height, we can kind of rule out doing any boreholes, for example. So seasonality and when you want to do this work can have a massive impact on program. And I'm going to give you an example of that later in the presentation. So that's me on site conditions. I'll hand back to Mike for the next stage.
So what are we talking about with site conditions and how do the FIDIC contracts deal with these, and particularly as Mark was talking about the design that comes with it? Now this varies again between the forms. Red and yellow in many ways are quite similar. Silver, as you might imagine, is a bit different. And again, there are some differences between the 99 and 2017 forms, and we're going to take a quick look through all of these as we go. We're going to start at the red and yellow books under the 99 form and clause 4.10. And what this clause deals with is the provision of information at the outset. So the employer must make available all relevant information on subsurface and hydrological conditions at the site that it has, and that includes environmental aspects at the outset. That's got to be provided before the base state, so we're really talking sort of tender stage around then, but then on an ongoing basis as well, because as more information comes in, you do want to improve the design, and that can have, as Mark has said, some very impressive changes in the contract price and some big savings if as the data comes in. The contractor, however, as far as possible, and we'll come on to what is meant by that, that timings wording in a minute, is deemed to have examined the site, to have obtained all necessary information on the risks and contingencies or circumstances that may affect the works or tender, and then have reviewed all information and satisfied itself on the form and nature of the site and hydrological and climatic conditions. Now, that could be an awful lot of information, as Mark was saying. If you're getting 40 or 80 years of data, and that's not just on wave heights, that could be on all sorts of things, it could be a very, very large amount of data. So this is where that, to the extent possible, given timings wording is relevant. When you are tendering a project like this, the longer you can give the contractor to review this data, the more responsibility they take on for it. If you give a contractor a week to review 100,000 pages of information, it's not going to be deemed to have reviewed all of it and be aware of everything. Conversely, if you give it a month or two or 3 or 4 months to review all of it, it will take on more of that responsibility, and it will be deemed to have included for more of it in its tender. You then come on to the unforeseeable conditions, and this is where it can really affect. We're now moving on to when it's on site, and there are two important definitions to understand. The first is physical conditions. So under the 99 form, as you can see, it's any natural or physical or man-made condition of physical obstructions, pollutants, subsurface, hydrological, but it does exclude climatic conditions. And what does unforeseeable mean? Because unlike many contracts, unforeseeable is actually defined by the FIDIC contracts, but it's defined as anything that was not reasonably foreseeable by the experienced contractor at the date of submission of the tender. So this again comes back to what is and isn't included in its tender. And if the contractor experiences unforeseeable physical conditions, it could then give a notice to the engineer, who will come and inspect the physical conditions. And then if they are unforeseeable, that notice was given and the contractor has suffered delay and or cost, then it's entitled to make a claim for that delay and cost. So having this information available early on minimizes the chances of later claims, improves the design from an early stage, and as we'll come on to, deals with cost certainty as well. But that's how the 99 red and yellow books deal with it. Moving on to the 2017, it's very similar. It's slightly different in exactly what has to be provided and when, but all relevant information still has to be given, but that includes topography of the site and also now includes environmental conditions. 4.10, again, it is deemed to have reviewed all of that information. It's again, to the extent it has the time to do so. Similar definitions, but they are changed slightly. You can see them there. The only possible change of significance here is the very end of it, where it now talks about the effects of those climatic conditions. The original definition in the 99 form talked about taking into account those climatic conditions, but not necessarily the effects of them. So that's one point to bear in mind. Unforeseeable is again very similar, but it's now defined to the base date, which is taken over the date of tender submission. Moving on to the silver book, the requirement to provide site data is very much the same as for the red and yellow, but the employer has no responsibility for its accuracy, sufficiency, and completeness, except for two possible times, and that is where the contract says that it is their responsibility, or anything the contractor cannot verify unless the contract says otherwise. So if the contract says that we know you can't verify this contractor, but it's still your responsibility, then it remains the contractor's responsibility. So because of that, unless there's a specific amendment, the contractor is deemed to have all the necessary information and it accepts full responsibility for any unforeseeable difficulties and costs. It still does mean, however, that the tender would come back with a better price potentially if the information is better that the employer provides. It just has no responsibility for its accuracies. But on top of that, there will be no adjustments for the contract price for either unforeseeable or unforeseen difficulties, and they are potentially two different things. So Mark, I think we're now on to financing.
Yes, indeed. So I've got two examples to just touch on this afternoon, both similar sort of value. This one was about $1.5 billion. So this particular project is funded by, well, I'll say it's a European funded project, but the approval and funding stage took 2 years longer than planned. So the contractor was appointed 2 years later than programmed, but the deliverable timescale due to financing funding stayed the same. Now, I'm sure a lot of you have probably heard that and come across that on projects. And that's obviously a big problem. So rather than the 6-year planned, it squeezed it into 4 years, which is very short for a marine project of this size and scope. What did that mean then? So the result effectively meant that data collection of the wave heights, remember I talked about that before, the client hadn't even put a wave rider buoy in. So started the design process, other studies, desktop studies, research had to be undertaken on nearby locations and other sites. So again, that did bring in some inefficiency in the design. The site investigations, remember I mentioned this? Well, exactly the thing happened here. Effectively, they got to a position of doing site investigations in October. With the increased wave heights, the site investigations were delayed, but the pressures on the designers and the geotechnical engineers doing the foundations designs were still there. So assumptions had to be made and then back-checked later once the geotechnical results were in. Not an efficient way to do a design. The numerical modeling was undertaken based on the data collection and assumptions. And usually we would do physical modeling. So it's not uncommon on our large marine projects to do physical 3D physical modeling in places like HR Wallingford or Deltares in the Netherlands or CSIR in South Africa and lots of other locations around the world. Usually we do that once the design is complete. This verifies the design. We look at wave pressures and wave heights. We build the structure at a 1 in 50 scale, so it's quite a large structure. That was undertaken at the same time as the design. So again, it caused the design process to trip up on itself. Not an efficient way to go at all. But importantly as well for the contractor, and this is potentially where a lot of costs occurred, is making the contractor into some unforced perhaps decisions on procurement in terms of volumes of material. On this particular project, I think there was about 15 million tons of rock fill and rock armor. So quite a large material. They needed to source that. And also plant resource availability. Floating plant is very expensive, and I'm sure some of you might have worked on marine projects and know that it's very expensive. It's often booked up in years to come. So again, it's an inefficient way to procure the floating plant they need to build these structures. Next slide, please, Mike. Okay, project number 2, $1.8 billion, similar sort of size. Similar thing really in terms of client's requirements, but this project was awarded just 2 months late, which pretty much is on time as far as the construction industry goes. But what happened here was the client had the foresight to undertaken lots of data acquisition. He'd undertaken some boreholes, not a full suite, but he'd done some data acquisition with a competent company that when we took on the design, we looked into that data and we basically took on that data because we knew the company, we'd worked with them in the past. So that helped in terms of some of the data acquisition, so the wave heights and the wave rider buoy information, some of the outline numerical modeling that I'd done. Site investigation as well, because again, it was in a less, there were very little storms in this particular region in the Middle East, and it's also in the summer as well, so there's no shamal winds or anything like that. It meant that the site investigations could proceed with the design coming in at the appropriate time for the designers. Likewise, modeling, numerical and physical. On this particular project, we did physical modeling in 3 countries because of the compressed design timescale, but we managed to do that at the appropriate time to validate the design. So again, the contractor, because it was only 2 months late starting, the contractor in his tender had assumed he was going to use certain floating plant. Those were available. So again, there wasn't the resource issue on that particular project. And as you can see there, by working well with the client, okay, yes, there were a few contractual discussions or meetings without chocolate biscuits, as I call them. We managed to finish the project 18 months early. So from start to design, to tender award, to completion of construction was 36 months. I think Mike can show you the next slide. So this is a particular project. Just to give some numbers here, really. I mean, yeah, 2.5 million tons of concrete, lots of materials. I think there were about 5,500 people working on site at one point. It just goes to show as well, if you kind of get it right and the clients, yeah, we're lucky here. Again, it was a competent client who had a good team advising them to provide all this data up front, that we could then move on into the design and the construction stage, and build this new port in 36 months from start to finish in terms of the port platform. Thanks, Mike.
I was just going to say, Mark, you mentioned earlier the availability and cost of some of the floating equipment. I know we've discussed this a number of times, but just for those who maybe aren't so familiar with marine projects, I think we're saying that even some of the smaller dredging barges and so on can be hundreds of thousands of pounds a day. I think that's the sort of scale we're talking here, isn't it, Mark?
Yeah, I mean, there's some of the bits of equipment. I can't remember how many dredgers we had on this particular project, but I can see in that picture there probably at least 3 cutter suction dredgers. You know, and they're you know, of large, you know, hundreds of thousands of dollars a day. Floating barges, I think there was something like 24, 25 mobile floating cranes on the particular project. I've got lots of data sheets with all the big numbers of how many bulldozers and things, but absolutely, you know, and this is where the contractor needs to plan, and the availability of that plant, floating plant, is expensive, sensitive to weather, which is why the programming is very important. So again, if you get a knowledgeable client who understands the risks involved in maritime work, there's bigger risks in maritime work, then that can help to actually mitigate costs and the cost of the project by planning ahead, rather than just getting the funds and giving it to a contractor and say, I need it built, you know, as quickly as. Certainly, I think with a knowledgeable client and working with them, as we did on this particular project, it does help a lot in terms of, and all the team partners, the whole stakeholders on the project as well. Help. So I just wanted to give an example of something where you know, we're talking about lots of issues often in our industry, but you know, this was a particular project where it went well. Yes, there were a few discussions, shall we say, but generally this project went well and finished early. So
If you can find a project without some discussions, I think you're doing very well.
Yeah. Okay.
But as you say, the prospect of getting it wrong, with potentially millions of dollars a day at stake, particularly if you're out of season, just in equipment, can be something that really does need to be considered at the outset.
Yeah, I mean, certainly on marine, on oil and gas projects and stuff, those on the call that might have worked on those will probably know. But you know, if you're working for Exxon or Mobil or someone on a structure like this, for example, where they're looking to export product on a certain date, if you don't hit that date, the LDs are millions of dollars a day. So yeah, it's important that you get these projects right from the outset.
Yeah, absolutely. But when you come on to look at financing the works and making sure you do hit those deadlines, there's a couple of things to look at, as we sort of talked about in the agenda section earlier. The first is how, as far as possible, you can get that cost certainty and get yourself onto program early on. And the second is giving the contractor confidence that the money is going to be there to get it paid at the end of the day. Cost certainty itself is in many ways a more of a commercial point, and a client being aware of what's going on and being sensitive to when things need to be done and how early it should get its contractor involved, and when it should start recording data as well, of course, as Mark's mentioned. But early contractor involvement is almost always of a benefit on these sorts of projects. And often the way you can do that is through a pre-construction services agreement or something similar, which then allows the contractor to develop the design early, as part of that, take its own readings as early as possible, get in early to review the information that you have in order to make sure that the design isn't over conservative, that the program is achievable, and that well, to the extent you need designs to help secure your funding, they are there at the right time. As it helps them to review the risks at that early stage, and to develop the full cost budget to the highest possible level of certainty, accepting that particularly with this type of project, certainty can be something of a relative term, particularly with the changes in climate we're going through. As to contractor comfort, and this is something which a number of clients over the years have asked about, the FIDIC contracts do have a mechanism to allow the contractor to make sure that money, well, I say make sure, to try and make sure that money is going to be present. The 99 forms contain this at clause 2.4, and that is when the contractor can request from the employer reasonable evidence that the financial arrangements have been made and are being maintained, at least up to the value of the contract price. That's the contract price following any variations at that time and estimating going forwards. And that information has to be provided within 28 days, along with reasonable evidence that it is in place. If the employer is making any material change to the financial arrangements, it has to give notice to the contractor with detailed particulars of those changes, because the last thing you want to do as a contractor is continue working when you're in that position. But that on its own is all very well, but and it has a simple intent behind it. These are large and expensive projects, as we've just discussed. Even missing a single day can put you millions of pounds down. They're often in parts of the world where, shall we say, confidence about being paid may be slightly lower. And the contractors do need to know that they're going to get paid and that the money is there. Under this form, the contractor can request the information at any time. It is a 28-day response period, and they've got to provide detailed information. But what happens if they simply don't provide that information? And that is clause 16.1. If the employer does not comply, the contractor has the option to give a notice to them, requiring them to comply within, as a minimum, 21 days. And if the employer does not comply, the contractor can suspend or slow its works until that evidence is provided. So this is not a clause that just sits there which the employer can ignore. There are some teeth that go with this clause. So if a request does come in, it should not be ignored. The 2017 form is slightly different in that it's not just on request. The funding arrangements must be set out in the contract data. At any time, as before, there's a material change which would affect the remaining payments, then the employer has to give details immediately with those detailed particulars. The contractor can also then make requests where it receives a single variation that's adds up to 10% of the accepted contract amount or more. The total of all variations is over 30% of the accepted contract amount. If it doesn't receive a payment, then of course it can make this request as well. Or if it becomes itself aware of a material change to those requirements, to the financing arrangements, and the employer has not given notice to it, then it can make that request for reasonable evidence to be provided within 28 days. So Mark, I think we're finally now on to the potential ramifications.
Oh, okay, thanks. Yeah, so again, a couple examples here, really, real world examples. One particular project, the requirement on this particular project was to reuse parts of an existing structure, or parts of an existing structures, I should say, that were being demolished. This is partly due to the requirement of the funding body, sustainability, so a lot of concrete to crush it and reuse it, or reuse, in this particular case, what I'm talking about here is the concrete cubes. And what I mean by that, as you can see from the little photograph there, these lumps of concrete were used to protect the caisson or seawall of an existing port. The new development required that seawall to be moved, or the caissons to be moved, new ones to be installed, and that the assumption that the tender made, the client made in the tender, was that the cubes and the rock armor were of a certain size. Now that's important for us as designers, because if you're moving them into deeper water, the waves get bigger, therefore the size of concrete or rock that needs to resist that bigger wave will increase. So again, it was stated that they were of a certain size, and that there were a certain number of them. There was a certain volume of these concrete cubes. So that was in the tender process, so, and that was on the basis of which the contractor priced his tender. The next slide, please, Mike. However, once appointed and after undertaking some dive surveys and inspections of the concrete cubes, it was found that they weren't really of the size that was stated in the tender documents and in the various attached documents to that. They weren't big enough, basically, to resist the larger waves and the more exposed parts of the new port. So new concrete had to be poured. So the whole concept of some of the funding was the fact that sustainability, no need to produce more concrete, was a fact. We had to make bigger cubes. And also the volume, there wasn't as much concrete cubes as first thought. In addition, with the rock armor, it wasn't as large, or there wasn't as much, so we had to reposition that within the concept or the design layout and make more concrete cubes. But this also has a knock-on to the contractor as well, because of course he'd priced his design, his cranes, to pick these blocks up based on these cubes are between 37 and 55 tons each. So big cubes, you know, they're probably as big as your lounge you got at home maybe. So it needed a certain size crane to pick these up, to move them, and to place them in the new position and in the new port. We actually had to, after physical modeling, remember I've talked about physical modeling and its importance, we actually were moved up to 72-ton cubes. So those of you on the call that are involved in construction will understand that a crane that picks up a 55-ton cube at what we would call flat stick, so basically putting it out into a distance into the sea, needs to be a lot bigger for a 72-ton cube than a 55-ton cube. So what are the ramifications to the contractor? Bigger machine. Now, how did the contractor assume that that crane was going to get out into those caissons? Is it wide enough for the new crane? So there's lots of these small little things which seem fairly insignificant, have big ramifications in terms of contractors' costs, claims, variations, and the such like. So just a small example here of some information perhaps not being quite right, how the ramifications going forward, producing more concrete, so moving away from some of the sustainability goals, getting bigger cranes in, taking longer to place them, all those sort of things. And I'm sure a lot of you have come across similar issues on other projects that you might have worked on. Next slide, Michael, please. Okay, and a couple of other things really which always crop up on projects. Some of them are very similar to on terrestrial projects as well. If you're working on a rail or a buildings or what have you, is working hours. Now, on the two project examples I showed you, the big projects, working hours wasn't a problem. It's 24 hours, 7 days a week, just move on. Perhaps in some of the more, where we're near towns and cities and villages, maybe for coastal engineering projects in the UK, working hours can be a big thing. And it's very important in the tender documents or the contract that it's explained how the working hours are limited, because we work tides. So there may be, if you say you can only work at certain hours during the day, there may be certain days in the week a contractor just can't work on site at all because he's limited. He's not allowed to work at night. Can he deliver materials at night? A lot of our materials come in by sea. A lot of the rock armor, for example, you see on UK beach projects comes from Norway or France or Sweden. They come on barges. Beach levels, now the next two, beach levels and weather conditions. Actually, I'm going to do a little bit more on working hours because I've got a couple of minutes before Mike can take over. It also, working conditions. So finished a project recently in Dungeness on the Lyd frontage. On that particular project, we had an active MOD firing range. So that was okay. They stopped firing for over the 7-kilometre frontage. So they stopped firing for the first 3.5 kilometres while the contractor got on with his work. However, environmental designations kicked in on this particular site. We have overwintering birds on the beach in the area, which meant that we can't do work between the end of October and the 31st of March. But on the 1st of April, a bird called the avocet arrives on site. An avocet is a Schedule 1 bird, which basically means that we can't work anywhere within 300 meters of an active nest. So as it happened, these avocets decided to turn up on April the 2nd. For 2 or 3 years we were on site and nest along the frontage. So again, all of a sudden we had these environmental designations. It's not just working hours, it's working conditions. So that had a major impact on the project as well. 1 year, had no avocets, contractor moved on. So again, there are certain uncertainties in all of this when you get environmental restrictions. Beach levels and weather conditions, very important on the data gathering. Talked about earlier on, several slides ago. The more information you can get on the beach level, the mobility of the seabed, for example, that impacts the contractor's access. It also impacts your design. Different parts of the world, you get a lot of volatility in the seabed. It's called around the area called the depth of closure, where effectively the waves and the currents and the storms have an impact on the seabed, how it becomes mobile. So the more information that the client has had on that and done all the studies early on, the more confidence gives you as a designer, the fact that you can work with your contractor team and actually come up with a design that's is suitable. Notice I didn't say fit for purpose. Weather conditions, again, always a contention. So often in a contract, you'll have a compensation event or a claim or whatever can be done over, say, a 1 in 10 year event. Now, unless you've got a good suite of data available for that, it always tends to end up in some form of dispute if there's a damage or there's big costs involved. Okay, because what does 1 in 10 year mean? From what direction and what are the conditions? It's, there's a lot of matters attached to that. So I could go on, but I'm just looking at the clock and I know we need some questions, so I'll allow Mike to finish off.
I can imagine it's always an interesting question to have with your employer, a conversation with your employer. Why aren't you working? There's a bird 200 meters that way and I'm not allowed to be anywhere near them. So, where does this sort of lead to, and what happens if these things happen on site? Well, advance warning is where we're going with this one. And this is not something that was actually ever included in the original 1999 forms, though it is commonly amended in. In fact, it was so commonly done that into the 2017 forms, they included a clause 8.4. And that is that whenever any party becomes aware of any probable or known future event which may adversely affect the work of the contractor's personnel, affect the performance of the works when completed. So this will come on, that will deal with the points around which Mark was making around the smaller cubes and so on. Increase the contract price, which I'm pretty sure most of the things Mark just was describing would do, or delay the execution of the works. Then either the party or the engineer must give a notice of that. And then the real purpose of this is, and it's obviously common in construction, that when an employer receives a notice of this type, they take it as, well, oh help, there's a claim coming and everything seems to break down. But the truth is that these are really to be used to try and resolve the issue in the most effective and cost-effective way possible. And that should always be borne in mind. So with that, was all we had on our plans to discuss today. I'm just going to, I'm sorry for everyone, make my face a little bigger. Thankfully, viewers also includes Mark's. And hopefully we can now take some questions. So I think, Mark, we've gotten away lightly today.
Yeah, well, we'll see if somebody starts typing.
Yeah, so if there were any questions, then please do put them in. Otherwise, we will bring the session to an end. I think I'm seeing a hand raised, but I'm not seeing any typing. So there is the chat box if you did want to type anything. I'll just give you 60 seconds more in case. Otherwise, we will bring it to an end. What have we got? I've got one here. I'm just going to Are the claims for nesting birds recoverable as a contractor? The answer to that will be it depends, and it depends on the point we were making earlier about what information has been included and provided for at tender stage and how long a contractor has been given to review that information, though probably the time review is less important on that. In addition, the contractor is generally deemed to have taken into account what is publicly known about. So if this is a known issue in the area, particularly where Mark was talking about the avocets down in Dungeness, it is a known area for their nesting. And I think when we were discussing it the other day, Mark, you said it depends on how warm the spring is. If the spring's warm, then they're more likely to be there. If it's cold, then they're not. Is that right?
Yeah, absolutely. So it was a known, basically a risk, effectively, in a known risk. So what seems to happen is that if we have these avocets come from all over Europe and Africa and things. So if we have a cold, blowy northern wind blowing down the channel, they tend to go to elsewhere. They tend to go to Pagham Harbour and Rye Harbour and other places. Whereas what the ecologists seem to say, if it's nice and warm spring, they'll turn up on site. And what Natural England did for us, unfortunately, was said that even if 2 avocets are showing signs of breeding, not just making a nest, then we can't work within 300 meters of them. So even if 2 avocets are kind of, looking at each other with lustful eyes, shall we say, that was considered a breeding activity. So again, there were lots of discussions on site when the avocets were nesting on site. But I mean, it was successful. Lots of chicks and things were coming. So obviously, effectively the environment won from that one, which is not a bad thing. So they are a protected bird. So. Yeah. But it was a known risk, and it basically effectively extended the works for 12 months, basically on site.
So in that case, I mean, obviously the Silver Book I said earlier is slightly different because unforeseen conditions are dealt with slightly differently. But I don't know whether this one was even under the FIDIC contract in that case, Mark.
No, it wasn't. No, it wasn't.
No. If you were dealing with a FIDIC contract there, then most likely the answer is probably not. It's something you should be taking into account and allowing for in your program and in your tender as well. If it was a more unlikely event or something which for the first time in 100 years avocets had happened to land there and nest, that might be very different. But in this case, no, it probably almost certainly not.
Yeah.
If it had been under FIDIC.
Just the ramifications of it extending site for a year, which basically, because of the Ukraine crisis, it pushed the price of biofuel up, which the dredgers use. This particular site, the dredger used 2,500 tons of fuel in 6 weeks, so that's 25 million litres, and it added £2 million to the cost of the project. For the delay in the dredger, we went back to marine grade oil instead rather than biofuel. So again, ramifications for things globally, locally can have quite an impact on cost of projects, as I'm sure we're all aware. So.
Yeah, I think I've just seen one more question pop up.
Okay.
See if I can find it. So it's quite small on here. Just see that. Okay. Can the contractor recover their costs for prolongation should they slow their work because the client fails to respond to their question of the contractor's comfort? The answer to that would be yes, because it is effectively a breach of contract by the employer and not providing that information. So they have a contractual right to slow or suspend their works in that situation. So that's a fairly simple one. And if you're operating under the 2017 regime, you'd put that through the clause 3.5 agreement and determination process. So if there are no other questions, thank you very much everyone for joining us today. I hope you found it interesting and maybe learned something from it. Our details will be on the slides if you do have any other questions you'd like to ask. But with that, we will bid you good afternoon. Oh, 1 minute, we've got one question has just popped up. Oh, you're very welcome, David. Thank you all.
Yep, thanks everyone.